Today we're going to put together something that we learned in Chapter 2 with what we've been doing lately, and that is inequalities. When you have inequalities that have more than one variable, you're going to need more than one line to graph them on. When we had an inequality that was simply x is less than 3, we could do that on a number line because one variable needs one line to graph it. But since we have a multivariable equation, we need two lines, one for the x-axis, one for the y-axis. But not only do we have two variables, we have two equations. We've been doing that all of this chapter, the systems of equations, but now we're going to kick it up even one higher notch and do system of inequalities. Sounds scary perhaps, but this one's actually easy. It's easier than the rest of the chapter, I promise. First thing we're going to do is go ahead and put both lines into a more familiar form, the one that you guys seem to like the best, which is the slope-intercept form. This means you need to solve for y. To do this in the red equation, I would simply add x to both sides. The resultant equation, or inequation, would be y is less than positive x, once we add x to both sides, minus 3. That now is pretty easily graphable. We have an intercept of 1, 2, 3 in the negative direction, and we have a slope that tells us to go up 1 over 1, up 1 over 1, up 1 over 1. We also know that our line is going to be dotted. All right, so as we draw our line, we make sure to make it a dotted one. And finally, if this were the only line we were graphing, we would see that it says y is less than, and we'd know to shade down here in the less than area. Be careful not to shade too darkly right now, because that's not actually our final answer. If we only had one equation, that would be our answer. But in this instance, we're looking for the area that's true for both inequalities. So we also have to graph the blue one. Again, I'm going to put it into slope-intercept form by adding x to both sides. That would give me y is greater than x plus 4. Oh, off the screen there a little bit. X plus 4. That gives me an intercept of 1, 2, 3, 4 in the positive direction this time, and a slope that again says up 1 over 1. Up 1 over 1 the entire way. Again, the line is dotted. This time it says to shade y is greater than above the line. Our answer, our final answer to this system, is the area that's shaded because of both lines. So as you look at this, what is common to both lines? Like when we did systems of equalities, we had two different lines that tended to intersect in one spot. That point of intersection was in fact our answer. Since we're talking inequalities, there's a lot more areas that are common to each graph. So everywhere that's shaded by both graphs is our answer. As we look at this, there is no area that's actually shaded in both graphs. One is shaded above one of two parallel lines, the other is shaded below the other of two parallel lines, so there actually is no area that's common to both. That happens sometimes with equalities. We had graphs where we had parallel lines that never intersected. There's no intersection of the shading part here, so very similarly, our answer would be no solution, because there is no area that's common to the shading of both graphs.